Let's talk about factoring quadratics where a is 1. So quadratic is ax squared plus bx plus c, but we're looking at the type of quadratics where a is 1. So it's just x squared plus bx plus c. So these are the typically easier kind of factoring. Having the a be something other than 1 complicates things. So here we just have to worry about the b and c. And if you think about what happens when you FOIL to get that quadratic from the factors, you have the values in the factor being multiplied together to get c, and then you have those outside and inside multiplications that get added together to get the middle term, the b. So we're looking then at c and b, looking for two things that can multiply together to get c and add together to get b. So you can look at c and just list factor pairs, things that you can multiply together to get that, until you find a pair whose sum is b. We'll talk a little bit about sometimes it's more really a difference rather than a sum, depending, or at least you might want to think of it that way, depending on whether things are positive or negative. But if there is no factor pair with a required sum, we would call that polynomial prime. It can't be factored. So sign rules, if b and c are both positive, so you need a positive product and a positive sum, then both factors need to be positive. Positive times positive is positive, and positive plus positive is positive. If c is positive and b is negative, so you're multiplying two things together and getting a positive number, but when you add them together, you get a negative number. They both need to be the same sign to get the positive product, but in this case, they both have to be negative. And then if c is negative, you're going to have one positive and one negative to multiply together to get that negative product. And then depending if b is positive, then the larger factor needs to be positive. So when they add together, the result is positive. If b is negative, then the larger factor will be negative, so that when you add, the sum is negative. So let's just look at some examples of these. X squared plus 7x plus 10. So we're looking for two factors. They're going to have x at the beginning of each, and we need to figure out what's being added or subtracted with x. Now, looking at this, the 10 is positive, so I need either two positive or two negative factors. The 7 is positive as well, so actually two positive factors. And I can start listing, looking at factors, pairs for 10. So 10 is 1 times 10, 2 times 5, and those are the possibilities. And looking at adding those together, 1 plus 10 is 11, that's no good, but 2 plus 5 is 7, so that works. Now, you probably will get to the point, if you aren't already, where on some of these, you don't even have to list out the factor pairs. You can look at that and just think a little bit about 10 is 2 times 5, and 2 plus 5 is 7, and it works, so you get those. So don't feel like you have to write out all of those steps if you don't need to. But if it's less obvious factoring, you might find that helpful. All right, the next example, x squared minus 6x plus 8. So looking for two things that we can multiply to get 8 and add to get negative 6. Multiplying to get positive 8, so same sign on both. In this case, both negative. 8 is 1 times 8. It's 2 times 4. Again, if both of those are negative and we add those up, the 1 and the 8 would give negative 9. That's no good. But the 2 and the 4, negative 2 and negative 4 is negative 6. That's what it needs to be. So that's what I'm going to put into the factors. All right, next example, x squared minus x minus 12. So I now have a negative product, a minus 12. So I'm going to have one positive and one negative factor pair. So then when I add those factors together, it really is more finding the difference. It turns into subtraction. So if I look at factor pairs of 12, 12 is 1 times 12. 2 times 6, 3 times 4. And the difference, if I subtract 12 minus 1 or 1 minus 12, I'm going to get either positive or negative 11. So I can just look at the subtraction and figure out afterwards whether I actually need the positive or negative 11. Obviously, I don't need 11 at all. Or I can go ahead and look and say b is negative. So I would need the larger factor to be negative for this to work right. But the 1 and 12 don't work. The 2 and 6, we would have the 2 and the negative 6 would be negative 4. That's no good. The 3 and 4, though, if it's a positive 3 and a negative 4, there's the negative 1. So that's what we need, a positive 3 and a negative 4. All right, and the next example, x squared plus 4x minus 12. So we have the same set of factors with the 12, but now looking at the 4 in there, and it's a positive 4. So the 2 and the 6 produced a difference of 4, but we want the positive 4, so the positive 6 and negative 2. The factors can be written in any order. So I can have x plus 6 times x minus 2 or x minus 2 times x plus 6. There's no reason that either of those is better than the other. So one more example, x squared plus 6x plus 9. So I need two things that I can multiply to get 9 and add to get 6. 9 is either 1 times 9 or 3 times 3. We have all positives here, so both positive, adding them together. 1 plus 9 is 10, that's no good. 3 plus 3 is 6, that's what we need. So this is x plus 3 times x plus 3. If you happen to notice that C is a perfect square, in this case, 9 is a square of 3, and then if B happens to be double the thing that C is the square of, then it's going to be a perfect square. You have the idea of like x plus a squared is x squared plus 2ax plus a squared. So if you see B and C having that pattern of B is 2 times something that C is the square of, then it's just going to be x plus that thing squared. You don't have to use that shortcut, though. You can just use regular factoring if you don't recognize those perfect squares. It can just save you a little bit of time if you can spot those. So that's factoring quadratics where a is 1.